Hello everyone. My name is Juan Apostle. I'm a software engineer and I'm also trained. Okay, so but that's not basically what I'm about to do in this video. So in this video, I'm about to share with you guys. I started studying more about design patterns and Node.js, using Node.js to build enterprise applications. So as I was studying that, I got to understand that just writing code is not the main thing. How do you design your application, your system to be maintainable, scalable? How do you design your applications to actually scale very well? How can it be more maintainable? How both even performance and stuff like that. So reading this book have really changed a lot of things about me. So I decided to actually build application, build a system that can actually demonstrate those. So as I started building a fintech production application, both the backend and the front end, but right now I'm still on the backend. Okay. Now I am trying to document everything that I'm doing. So I started building it at, I'm in day 44 right now. I'm building it in around 120 days. It might be more than that or it might be less than that. So every day I document exactly what I do. So now today in day one, all right, in this video, I'm going to show you, all right, exactly what I do. Basically, I'm showing you the architectural design, not basically the code. It's just the architectural design of this system. So now, today, I'm actually starting the 120 the engineering journal to build a real fintech application from scratch using Node.js, TypeScript, Express, Prisma, MongoDB, and showing production engineering practices. Now, basically, in this video, I am I'm just using Express. I'm not using Nest.js or even Fastify. I'm just trying to, like I said, this is more of the architectural design. Okay. Yes, Express is still good. Fastify is better. Nest.js will even be better. But right now, this is still a monolithic application. I'm just building the MVP. Okay. So I can actually scale from that and maybe rebuild later. So now, but unlike most tutorials, I am not starting with UI screens or authentication. No, that's not what I'm doing. I have other tutorial. I have tutorials that I make and I show you. We start building all these things from the UI screens or authentication. No, in this, I'm starting with the architecture, the testing, the infrastructure. All right, because that's what re-engineering teams care about. All right. So currently, I'm actually seeking for a job as a software engineer, and that is why I am building towards this. So. It's not about just writing code, it's about the architectural design, the testing, the infrastructure. All right. So in day one's goal for me is just to bootstrap the backend foundation of the system. Okay. I'm just today, day one is just more of setup. Okay. So I am setting up TypeScript, Express.js, Prisma, MongoDB. So this is what I'm using to build. Or I'm using Vitest and Supertest for my testing. And then I'm using Turborepo, monorepo architecture. So I am basically using monorepo architecture to do this. I'm going to also explain all these things as I go on. So, and most importantly, it is test-driven development. I am writing tests. Normally, I used to write applications without test-driven development in mind. But at the end of the day, when I build applications, I maybe refactor my code or make some changes in my code. At the end of the day, you see my code will break, my system will actually break. So, but with test-driven application, I write my test first, then I will write the code. Then even if I now refactor, I will write the code to make the test pass. Then even if I now refactor or I'll make some changes, I will test my test. If my test fails, that means the system is no longer the way it is supposed to be. That means something is wrong. So I'll have to figure it out, sort it out, and make it work again. So basically, that's what it is. Okay. So test-driven development is something that I have come to embrace. Yes, it is time consuming. Yes, because you write tests, you try to make your test. It can, when I started, it was frustrating. But the thing is this is the best way. I remember the first application I wrote. All right. When I write these applications and then I make some changes. Users will start complaining. Do you understand? So one or two things will break. I didn't understand. So, but with test-driven development, everything makes sense. So in fintech system, mistakes are expensive. That is why I have to make sure that This might not be the best design actually because it's just only me that built this. Of course, if you want to build big systems like this, you should have senior engineers, more than one, not just only one person. I am designing, I am building, I'm coding, I'm doing everything my database, so it can be very, very frustrating and overwhelming. But I'm just doing the best I can do here, but I think I did really well. So that's what I'm showing you here. So mistakes are very expensive. You cannot A small bug can affect transaction, balance reconciliation, settlements, or financial records. And you know when these kind of things happen, this is money we are talking about. Your customers cannot pardon you if they lose their money. So this has to be top notch. Yes, my own system right now might not be that top notch, but the thing is that I get to understand these infrastructures. I get to understand this architecture on how to build these systems. All right. So that's why I decided to start with testing from day one instead of treating testing like an afterthought. Test-driven development is perfect for this because I have to write test, then write code to make the test pass. Then once it has passed, then I can go on and refactor, make some changes in my code, and then come back to my test and make sure that my test also pass. Okay. So the first thing I wrote in my day one was not the API, it was the test. That's the first thing. All right. So the health test is the first thing I wrote. So let me show you. So this is the test I wrote. So I'm actually trying to make sure that there's this route that this request will actually succeed. So if I go to, let me show you let me show you some of my code. So this is the health test. All right. This is the health test. Right now, let me go back and let me go to my app and let me make it fail. First of all, this is the input, but let me make it fail. All right, then I'll go back to my test. I'll go back to my test. Okay, wait, let me bring up my test again. Where is it? Okay, so let me go back to my test. I have it around here. Okay, now this is the test. All right. First of all, I have to write this test before I could implement it. So now if I go to check this my test, I could just do np, let me do cd apps API tests. All right. So I could do nps routes because that's where it is. npl routes, then health dot test dot ts. That's the file. If I run it now, it's supposed to fail. It is supposed to fail. That is, oh, sorry. MPS Vitest. So I didn't, it should be Vitest. Then it's supposed to fail. It will run and it will fail. This should fail because I didn't have I canceled the implementation. You see, it has failed. So it's telling me that now, because it is test driven now, I'll make sure that this test passes. So for it to pass, I'll go and do the implementation. So, but I'll come back to the implementation. I'll show you that. But this is what test driven development does. We have to first of all write tests that will fail. So I will before I will ship this application or even push it to my GitHub, I will have to make sure that every of these tests have to pass. These tests have to pass. So if it doesn't pass, that means something is wrong. Okay. So now I'll come back to the implementation and I'll show you how I did it. So this is the test, checking for the health test. So why did I do this health test? This is a very simple test that establishes the engineering culture of the project. Now, the thing is that we write expectations first, and we implement the behavior second. Then we might now maybe refactor or write more code as we go. Then as we make our make changes in our code, we come back to also run the test to check. Okay, so why monorepo? Monorepo, one important architectural design that I made in day one was using monorepo, and I used Turborepo. Although I do not understand Turborepo too well, like that, but I just use it to initialize my program. But I understand what monorepo is, okay? Instead of having that, because this application is going to contain so many services, all right, so many services. So instead of having them in different repositories, I just have to put them in one repo because there will be a lot of shared packages, so they can communication will be easy. So why? Because fintech systems rarely stay at as one service forever. When you're building a system as big like this, you have to divide them into there are different services, notification service, authentication service, and there are common, it's so many services that you are going to have. Do you understand? So they have to be separated in a way. So now eventually you may have API services, your background workers. Yes, you can have your background workers, your notification services, admin dashboard, shared packages. All right. Now a monorepo helps organize all of that in a scalable way. Do you understand? We can have all these things and they can communicate with each other, share business logic together, share maybe TypeScript types together and stuff like that. Do you understand? So a monorepo will help us to organize. And it is easier. You could have argued, why didn't I use maybe Polaripo or what? First of all, this application is MVP. First of all, it's not going to be that too big. All right. But secondly, with monorepo, these different services can actually easily share data. So Polyloop is not really required right now. And moreover, I said I'm trying to build this in as small as I can build it. Then I also use TypeScript. So why did I use TypeScript? I'm also using TypeScript with strict typing because financial systems require strong guarantees. If you have built application using JavaScript before, you will see that it can be very, very frustrating, especially at runtime. When your application is in production, people are using your application. Something of a common mistake of, oh, this variable was not supposed to be null or undefined, and it was not undefined, and you were trying to you make some function call on it. It might give you type error and all those things, but you cannot find them out at compile time. But with TypeScript, it helped me to catch bugs earlier because it will give me compile time catching, give me compile time errors, okay, to improve my refactoring safety. Now, when I make some changes, I might make some changes and maybe I make some changes in my arguments or in the fields of a particular data type or stuff like that, and TypeScript would actually catch it too. It helped me just like those kind of things we get in C# in those static languages, all right, static type languages like C#, like C++. TypeScript also help me get that. It enforces contracts. So if I say that I am giving a particular function, if I let's say I have a function and that this function is taking a string as an argument, I can never go and put in an integer there. So it enforces contract, model financial domains, it modeled our financial domains properly. So this becomes extremely important as the system grows. Normally, the system will grow. The Global Journeys is one of the platform I started. It's my online learning platform where my students actually go online to learn. Now, when I started building that, I didn't have all these things in mind. I didn't put all these things into consideration. But at the end of the day, my system started growing so big. Do you understand? And it was very hard to maintain. All right. So how did I implement the health check? Remember, my test is already failing. So how did I implement it? My test is already failing. So for me to implement it, I need to make sure that I have this route, this get route, this health route. I need to have it. So in this test now, I'm actually requesting, I'm making a request to this route, and I expect it to give me a status of 200, and also the body status has to be okay. So now let me go to my app.ts. That is where I implemented it. If I go to my app.ts, so now if I uncomment this, you can see now that okay, it has, look at it, it has restarted, and you can see that it has passed. Do you understand? Okay, you can see that it has passed. So you look at what I'm doing here. There is this route, this endpoint, this route or this endpoint. So it is, first of all, it's available, and second, it is returning a 200 status code, and then the body, the return, the resource.body has a status of okay. Do you understand? So you can see now this test has passed. So this you can see now because if I make any mistake here and say that instead of returning 200, I am returning 500, there'll be, if I'm returning 400, look at it, to fail again. So in case I make any mistake, in case I make any mistake, you can see that it will tell me, oh, something is wrong. Your test is not passing. So that is why test-driven development is amazing. So if I correct it now, everything will be fine. All right. Okay. So after writing the failing test, I implemented the health endpoint in Express. So app.get health and returning all these things. Okay. So that is the implementation. Now the test actually passes. So pass health test, this might look small, but health endpoints are actually critical infrastructure in production systems. Now there are other endpoints that needs to be checked, like the live and ready, but I didn't do that, okay, because I don't know. I am not using most of those things are actually used by infrastructure tools like Kubernetes and what's it called again, and Docker container. So, but I'm not using that. Like I said, I'm trying to make this as small as possible. I do not have too much. I don't know. I understand Kubernetes and container Docker containers right now. As something I'm going to learn in the future. So, but I'm going to be deploying using render. My backend and my frontend will be faster. As simple as that. So they are used for deployment verification. So we are using with this head test. Most of these infrastructure tools will actually check to know that, oh, is this application running? Like, is the server or the application running? So it helps us to do all these things, but that is it. So what are the engineering lessons? After day one, the engineering lessons, one thing I'm learning already is that senior engineering is not about building features quickly. All right. As I was reading this Node.js design patterns in Node.js and also building enterprise distributed, what's the title? The building distributed systems with Node.js, enterprise level distributed system with Node.js. I get to understand that no, it's not about building, writing code or building features quickly. It's about building maintainable system because your system will grow. Your system will definitely grow. So when they grow, maintaining them will now be very difficult. There will be errors popping from left and right. Okay, creating scalable foundation. So your system will grow. How do you scale them? Reducing feature risk. Like I told you, if as your application grows, there's more risk that you might have made some mistakes somewhere and there. So as you're using TypeScript, as you're using all this architectural design here, it will help us to catch all those things. Making refactoring very safer. So if I change my code, all right, I'll be very sure that first of all, TypeScript will help me when I build the system. When I build the system, TypeScript will help me to check if something is wrong, and then I would also run my test to see that if all my tests also pass. Okay, so most developers skip architecture early and pay for it later. Like I told you, the global genius, I'm rebuilding the global genius actually. I'm rebuilding it, and this is one of the reasons why I'm rebuilding it because it's getting bigger, it's growing, and it's very hard to even maintain. So I'm rebuilding it. I'm using some of this architecture. So I'm using this to practice and get all these things and I'll have a better understanding of it. And then I'll go and rebuild the system with that. Okay. So what next? On day two, I will continue the setup. Now I will do the setup for the backend and begin implementing more production-ready architecture patterns for the fintech system. So if you want to follow the entire 120-day journey of building it, I will be dropping them whenever I have time to make such video. Whenever I have time, I'll make such. But the thing is that I'm going to be showing you what I did. I'll be documenting the architectural decisions. Any architectural decision that I made, I'll tell you why I use that. Okay. I will show you the backend engineering, the testing, the scalability, the debugging. I'll be showing you system design, production patterns, and all this. So if you're really interested in learning, or understanding more. Maybe you are a developer already, you are just building CRUD applications and all those. You want to go higher, you want to do something bigger. Follow this journey, subscribe to my YouTube channel. And I also have a 6 months program where I train software developers or who want to be job ready in 6 months. So we build 4 applications, 3 applications, fintech application, AI power fintech application, logistic and escrow system, and also a WhatsApp clone messaging application. Okay. So thank you very much, and I will see you in day 2.